So let's say we have two functions. We have f of smiley face is tangent of smiley face, and g of x is equal to x to the 9th. So what would f of g of x be? Well, I'm going to take f of smiley face, and I'm just going to replace smiley face with g of x everywhere that I see smiley face. So this would become tangent of g of x, which will be tangent of x to the 9th. What is f prime of smiley face? I take my derivative, and I have my pattern here that I've learned of tan sec sec. This is going to be secant squared of smiley face. So what would f prime of g of x be? F prime of g of x will be secant squared of g of x, which will be secant squared of x to the 9th. G prime of x would be 9 times x to the 8th using power rule. Well, you probably see why we've done this. These are the pieces we need for chain rule. So if we had f composed with g, if we had f composed with g of x, that just means f of g of x. And so we'd be looking at the function tangent of x to the 9th. When you see f, that means find the derivative of tan x to the 9th. Well, this is where we're going to use chain rule. So d by dx tangent of x to the 9th is equal to secant squared of x to the 9th times 9x to the 8th. So some people get to a place where when they need to take a derivative of these composite functions, they can just do this trick where they say, take the derivative of the outside, leave the inside alone, and then take the derivative of the inside and multiply the two. If you feel like that works better for you versus doing all of the structure we've laid out, I won't argue with you, and there are lots of people who can do it that way. But I do think it's important at some point to break it down and see that process where you go with all of the pieces laid out.